Hi everyone, welcome back. This is Jim Martinez again with the 8th grade science channel. Today we're going to be learning about identifying valence electrons with our TICS 8.5b, protons determine an element's identity, and valence electron its chemical properties. Let's take a look at the previous knowledge. Several things that we have learned before, like the parts of the atom, characteristics of particles, meaning of the atomic number. We have learned about the atomic mass, how to arrange electrons, identifying elements and atoms, and at the end, putting everything together to draw the atomic structure. So what are valence electrons? Since we're going to be learning about this, we need to talk a little more about it. Valence electrons are electrons that are on the outermost shell. That will be the last shell. What we say with shell, we can only call them energy levels. All right. They can be gained, lost, borrowed, shared. All the electrons on the outer shell or on the last energy level, there's a lot of things can happen to them. You gotta learn about it. They determine the reactivity of the atom, and they also determine the chemical characteristics of an atom. Let's practice identifying these atoms and make count of the valence electrons in these atoms. Like for example, this has one proton. We can see the count right here. Okay, electrons, notice that there is none, so we have 0. I'm sorry, neutrons. Neutrons supposed to be in the nucleus. We don't have any, so that's 0. Electrons, we have 1. Valence electrons, remember those are the electrons on the outer shells, but since we only have one energy level right here, so therefore that will be the 1. So valence electrons will be 1. Energy levels, we got 1. The mass, since we only have one proton in the nucleus, we don't have any neutrons, therefore it's only 1, since we have one particle only. The atomic number is the number of protons. Remember, that is 1, and this element will be hydrogen. Let's move on to the next one. Okay, if we may count again, we're gonna have 2 protons. These are the positives, 1 and 2. So protons is 2. Neutrons, we have 1 and 2. 2 neutrons. Electrons, we also have 1 and 2. So therefore, we put a 2 here. Valence electrons, once again, we have only one energy level, so this will be the outermost shell. So therefore, we have 1 and 2, which is the same amount of electrons. Energy levels, we only have 1, and the mass is adding these 4 particles inside, so that's 4. Atomic number will be the number of protons, so we have 2. And the element, this will be helium. Let's move on to the next one. Here we're going to have the protons are going to be the blue ones. They are going to be 1, 2, 3, 4, 5, and 6. So we got 6 protons. We got 1, 2, 3, 4, 5, and 6 neutrons. Electrons, we have 1, 2, 3, 4, 5, and also 6. Valence electrons, remember those are the electrons on the outer shell. So this will be the outer shell. This one on the outside. So therefore we got 1, 2, 3, and 4. Valence electrons, we have 4. Energy levels, we got 2. This will be 1 and 2. The mass will be adding all the particles inside the nucleus of the atom. So we got 6 protons and 6 neutrons, add them up. That will give you 12. So the mass will be 12, and the atomic number will be the number of protons, which is this one's right here. That will be 6. Or the electrons, also we can use the electrons to find the atomic number. So that is 6. The element, this one will be carbon. All right, let's move on to the next one. What we have here is neon. I put neon there. That's the way that it's going to appear on the periodic table. And we're pretty much going to be adding the atomic structure. So that way we can combine a lot of knowledge that we have gained before. So we know we're going to have 10 protons. I'm not going to put every single particle. I'm just going to put 10 positives. There you go. And then we have neutrons. We're going to have 10 more because the mass is 20. And remember, adding 10 plus the neutrons, that should give us the mass, which is this number right here on the bottom. Right, so that's 20 neutrons, 10 neutrons. Then we're gonna have one energy level. And since we have 10 protons, we're also gonna have 10 electrons. So we're gonna have 2 electrons on the first energy level. And if we add one more, that will be 8 more because we need 10 electrons. So we got 2 on the first energy level and 8 more on the second energy level. So there you go. This is the complete atom. Now let's start making our counts. Protons, we have 10. Those are the positives. Neutrons, we have 10. Electrons, we have 10. Now valence electrons, remember this is today's topic. That's why we're focusing on these ones. Those will be the electrons on the outer shell. So we got one shell right here, and this is the shell number 2. Okay, the second energy level only has 2, 4, 6, and 8. 8 valence electrons. Energy levels, we have 2, and the mass, 10 plus 10, that's 20. Plus we have this number over here, so we can tell, we can correlate or check that, make sure our math is correct. The atomic number is this number on the top, or the positives. Also the negatives can be used to find the atomic number, which is 10, and the element is neon. We will move to the next one, and here we have protons, we got 9. Neutrons, we got 10. Electrons, we have 2, 4, 6, 8, and 9. Valence electrons, remember those are the ones on the outer shell. This is the outer shell. So we got 2, 4, 6, and 7. Valence electrons are 7. Remember, those are the ones on the outer shell only. Energy levels, we got 2. The mass is 9 plus 10. That will be equals to 19. So the mass will be 19 AMUs. Atomic number will be the protons, which is this ones. That is 9. And the element will be fluorine. Let's move on to the next thing, will be chemical properties and reactivity. So how do we know if these elements are reactive, or how are they going to react, or what will be the chemical properties? We actually can predict what will be the reactivity, or how some elements interact with each other, because we know the amount of valence electrons. So pretty much like the universe is in a tendency of balance. That's pretty much a constant. Our universe has a tendency to balance each other out, or balance everything out. So here we are going to be putting as an example this compound. This is sodium chloride, or just simply known as table salt. Right? It's made of 2 elements, sodium and chlorine. If I make these 2 atomic structures, I will have 11 protons. I will have 12 neutrons. And if we add, or we put the energy levels, we're gonna need 11 because we have 11 protons. We're gonna have 2 on the first energy level, 8 on the second energy level. But we need 11. So far we have 10. So we need to have 1 more. There you go. So that's the last one. I'm just gonna put them here. There you go. I'll scratch this one out. Now chlorine. Chlorine has 17 protons. Okay. This is 35. So I'm just going to put the electrons on the first energy level. That's 2. we need 17. So we need to add another energy level, and we need to add 10 more electrons. Now we have covered the rules on how to put electrons on all the energy levels, so we're not going to go in details about that. So we got 10 electrons so far. We need 17, so we need 7 more. If you look at this last energy level, you will have one there, and 2, 4, 6, and that one's on. It's going to be 17 in total. Notice what's happening over here. We can predict pretty much that these two elements are going to be joining or coming together, because this one has only 1 valence electrons on the outer shell, and this one has 7 electrons on the outer shell. So in order to balance that third energy level, which is balanced energy level, will be having a full load of electrons around them. So the third energy level can have a maximum of 8 electrons. So if this one has 1 and this one has 7, the most sense that we can come up with is that these two are going to join together. They're going to create table salt, and this is something we can actually predict, right? So we can know chemical properties and also reactivities by knowing the amount of valence electrons, and this will be an example of it. And we know that the tendency of balance is always going to help out and can let us know with pretty much very accurately that which elements can combine and come together and share electrons or gain or take away electrons. Or we have another example, but that one is going to be for you later on. Okay, so today we have learned that electrons on the outer shell are called valence electrons. Valence electrons can be easily identified just by counting the electrons on the outer shell. Valence electrons determine chemical properties and reactivity. And valence electrons are also cool. Well, we can consider them to be cool because they are. Okay, so this is pretty much everything we have for today. This is Jim Martinez once again with the 8th grade science channel. Thank you for watching, and subscribe if possible. Bye bye.